In order to learn about pointers, we first have to start with the address operator. We can get the address of any variable by using the address operator, which is the ampersand. Every variable in a program is stored at a unique memory address, and that memory address is in hexadecimal values, which remember has 16 digits including 0 through 9, and then it starts to use letters. So A is 10, B is 11, and so forth. So in some of my slides, I just make up a memory address, and you'll notice that it has letters and numbers because that's what a hexadecimal value looks like. Okay, for in this slide, we have num, which is assigned 4, and so you can see I drew that like it would be in memory down here in the bottom left. And then I print out the memory address of num. And so I'm using that address operator in order to do that. So what would be printed out? 4DE32 is what will be actually printed to the screen here. Okay, so now let's talk about pointers. A pointer, the idea behind it is actually really simple. A pointer variable is just a variable that holds a memory address. And so usually the way that I draw it is with a box and a dot in the middle, and that's how I draw a pointer. But what's actually happening, if this is a pointer variable in this bottom box that I'm hovering over right now, then it's going to hold the memory address of a particular variable. So this pointer holds the memory address of num. We could also say that it points to num. We've used a couple of things that are like pointers, and one of those things is arrays. So when we pass arrays as arguments to functions, remember I said they are automatically passed by reference. But really what is being passed is the memory address of the very first element in the array. So let's take an example of calling a function called showValues and sending an array called numbers, and where size is the size of the array. So here's the numbers array, 5 elements. And when I actually pass numbers to the showValues function as an argument, it takes the memory address of the very first element of numbers and places it inside of values here. So values is now just another name for numbers, and it contains the same memory address that numbers does. So we can use values as the array name in this function. Another thing that is like pointers is reference variables. So remember how we use reference variables. We put an ampersand, which you now know is the address operator, in front of the name of the parameter. And what this does is it allows us to pass the memory address to this function of this particular value so that we have access to the calling function's original argument. So let's take a look at the next slide. So let's say we have in a main function, we have a jelly donuts variable. And we call a function called getOrder, sending jelly donuts to that function. But we're not actually sending a copy of what's inside of jelly donuts. We're sending the address. And that address gets inside of donuts, and so now donuts is just another name for an alias for jelly donuts. So pointer variables are yet another way of using a memory address to work with a piece of data that you have stored on your computer in memory. Pointers are more low level. And when I say more, I'm comparing them to arrays and reference variables. This means that you're going to be responsible for finding the memory address that you want to store in the pointer and correctly using it. This will make more sense as we work with pointers in this module. So, how do we define a pointer? Defining a pointer, you have to put the star in front of the variable name. And then you also have to indicate the data type of the variable that you're going to be pointing to. Or in other words, the data type of the variable for which you're holding its memory address. So the way we would say this is int pointer can hold the address of an integer. All this does is create the pointer, but it didn't actually put a memory address inside of that pointer yet. So right now we have a pointer that points to nothing. One thing I want to point out is that the spacing in the variable definition does not matter. So you see three ways of being able to space. So in this top example, we have the data type, a space, the pointer operator, and then the name of the variable. And down here, we have a space between both the data type and the variable name. And the third example is putting the star or the pointer variable attached to the data type, then have a space and the name of the variable. It really doesn't matter. They're all three the same. They do the same thing. So now that we have a pointer variable, how do we make it actually contain the memory address of another variable? This is how we do it. So I have my pointer called int pointer, and then I set the memory address of num inside, or I assign the memory address of num to int pointer. And that's what creates this connection where int pointer points to num. This is what it really would look like in memory, where we have the memory address, a hexadecimal value, stored inside of int pointer. But this is how I typically draw it, just because we don't know what the memory address actually is. And it'd be different on everybody's computer and every time you run the program. Now you can initialize a pointer variable. So if I wanted to initialize this so that it really does point to nothing and doesn't have junk data in it, I can do that by either using null pointer or null. Prior versions of C++ uses null, and newer versions of C++, starting with 11 and greater, uses null pointer. So in my code, you're going to see both versions. All right, let's take a look at these two examples, address operator and basic pointer underscore one. I already have my Module 6 example programs folder open, and I'm going to open up my command prompt in this folder, in this directory, and open up VS Code. And I wanted to look at address operator. So remember, the address operator is the ampersand. So this example shows me creating a integer variable num and initializing it to 5, printing out the variable num, so that's going to print 5 to the screen, and then printing out the memory address of num, which I don't know what that's going to be, but it's going to be a hexadecimal value. And I need to mention something that is in the slide, but I need to mention that hexadecimal values always start with 0x. And that's just to indicate that it's a hexadecimal number and not just like a base 10 number. Okay, let's compile this program. Address operator.cpp. All right, so it print out 5, and then it print out the hexadecimal value B4AA BFF62C. Really long memory address. I usually don't write the memory addresses that large in my slides, but that's what it is on my machine right now. Okay, one other thing I should point out before I get to the next example is that notice that you don't have to include any libraries or anything to use the address operator. Basic pointer 1 is the next example I wanted to show you. And basic pointer 1 first creates an integer variable called x and initializes it to 25. Then creates a pointer variable that's allowed to point to an integer and sets the pointer variable to be pointing to nothing or null. We could also use null pointer here. Then it prints out the address and pointer before x and prints out the pointer, which should actually, what I think will print to the screen is a 0, and that indicates that it's pointing to nothing. And then line 18, we take the memory address of x and we place it inside a pointer. Then it will print out the address. Sorry, all this stuff keeps popping up. The address of x is memory address of x. The size of x is, and I use the size of function, which returns the number of bytes that x is in memory, which should be 4 bytes for an integer. Then line 22, it prints out the value in x is, and it should print out 25. And then line 23, the address of x is, and then it'll print out the memory address. Now I'm going to run this program. And of course, these programs don't really make sense. Like, you wouldn't actually just write a program that does this, but this is just to demonstrate the basics of pointers. Oops, I think I actually accidentally closed out my command prompt somehow. Okay, G++ basic pointer underscore 1.cpp. So the address and pointer before x is 0. Remember, that's our null. The address of x is, and this indicates that it's hexadecimal, and then here's my hexadecimal value of the address of x. The size of x is 4 bytes. The value in x is 25. The address of x is, and we have the same memory address. Just note that we're printing out the same exact thing here and here, but we're doing it in 2 different ways. If I pull up the code again. So here we print the memory address of x using the address operator, and here we print the memory address of x because it's stored inside of that pointer. Once you have the pointer, right, we have a pointer, it points to a variable, we can print out the memory address of the variable, but then what? Well, you can now access the value of the variable that you're pointing to by using the indirection operator. Now, unfortunately, C++ uses the star again for another purpose. So there's 3 purposes of the star in C++. 3 purposes. You learned the first one a long time ago when you learned about arithmetic operators. And so it is multiplication. I'm going to write 3 purposes of the star. Okay, 1 is multiplication, 2 is to define a pointer, so it's the pointer operator. And the 3rd purpose is on this slide, to dereference a pointer. Dereference means that I am accessing the value that this pointer is pointing to. Okay, so in this example, I have x, which is 25, just an integer, and then I created a pointer, int pointer, and I initialized int pointer to point to x, so it holds the memory address of x. Then, if I want to print out x through the pointer, I can do that by dereferencing the pointer using the indirection operator. So cout, and then our indirection operator, int pointer. So this line right here defines a pointer. This line right here dereferences a pointer. They're actually 2 different operators. And how do you know the difference? Well, you know this is defining a pointer because we see the data type here on the same line. And if you don't see the data type and you're using the pointer and you see the star in front, that's the indirection operator. We're dereferencing it, and it's talking about the value that this pointer is pointing to. Now, I already talked about the hexadecimal number system, but this slide talks about it a little bit more. All right, let's take a look at basic pointer 2 through 5. Basic pointer 2 is very similar to basic pointer 1, except we added one more line of code, which prints out the value of x using the indirection operator and the pointer. So dereferencing the pointer. So I'm going to clear the screen, compile this program. The address of x is CB6F3FFCE4. It's 4 bytes. The value in x is 25. The value in x is 25. So it looks like I just printed out x twice, but actually the first time the value in x is, and I print out the value of x using the x variable, and then the second time I use the indirection operator, but notice that it printed out the same thing. Okay, let's take a look at basic pointer 3. This example is also exactly the same as the last, except this time I used a pointer named dog. And I did this because I think it can be confusing at first to note that even though I usually use PTR or int PTR, you don't have to name the pointer that way. It's a variable name, so you can name it whatever you want. So our pointer here is dog, which is silly, but it's just to show you that you can do that. It's a variable name, just like any other variable name. And basic pointer 4. This is a good example to show you that you can actually change the value of a variable through the pointer. So I'd like to draw out kind of what's happening here in memory and with the pointer. So on line 15 is where we create a variable called x, and it's initialized to 25. And then on line 16, I create PTR, which is a pointer, which doesn't yet point to anything. And then line 17, I make that pointer point to x. I put the memory address of x inside a pointer. Then line 20, make this a little bit smaller. Line 20, it says, here's the value in x printed twice. And it will print out x, which is 25, and then it will dereference the pointer, which will also print out 25. Then line 26 will change what pointer is pointing to 100. So instead of 25, this value is now 100. Then I use line 30 and 31 to print out x and then print out the value of x again, but using the pointer. So this is going to print out 100 2 times. Okay, let's look at one more example where I have a pointer and I have several different integer variables. And this is a good example to show you that you can change what memory address a pointer is holding throughout your program. So I create x, y, and z on line 13 and initialize x to 25, y to 50, z to 75. And then I also have a pointer variable that's allowed to point to an int, but it doesn't point to anything yet. Line 17 and 18, I print out, here are the values of x, y, and z, and it'll print out 25, 50, 75. Then line 22, I put the memory address of x and place it inside a pointer. So that's going to create that connection right there. So that pointer points to x. Then this line right here, line 23, is going to take the value that pointer points to, add 100 to it, and then place it back in the value that pointer points to. So basically we're adding 100 to what's already in X, so it's going to change it to 125. Then line 25 takes the memory address of Y and places it inside of pointer. So pointer now holds the memory address of Y instead of X. Then we take the value that pointer's pointing to, add 100 to it, and then put it back inside of the variable that pointer's pointing to. And so this is going to add 100 to 50, which will be 150. Then line 28, we will take the memory address of Z and place it inside a pointer. So that will make pointer point to Z like that. And then line 29, take the value that pointer is pointing to, which is 75, add it to 100, and then place it back inside the variable that pointer is pointing to. So that'll make this 75 a 175. Then lines 32, 33, I print out X, Y, and Z again. Okay, I'm going to run this one for you. All right, here are the values of X, Y, and Z, 25, 50, 75. Once again, here are the values of X, Y, and Z, 125, 150, and 175.